are the basic operations of the digital image processing. Okay, so remaining we will see in the next class. AMM School of Engineering, Department of Mechatronics Engineering, online classes, subject RMVS, that is Robot Machine Vision System, unit number 5, that is Robot Vision System. Okay, that means in this unit we are going to discuss about the image processing. Okay, so last class we discussed about different types of elements used in the industrial robot for identify the object correctness. Okay, then basic processing of the digital images like that we discussed. Now we are going to discuss about the relationship between the pixel from one pixel to another pixel, how to relate the informations. Okay, neighbors, adjacency, path, connectivity, region, boundary, and distance. So basic relation between the pixels with respect to the coordinates, that is variations of the coordinate within the horizontal and vertical and diagonal concepts. So adjacency, so that means defined as two pixels are adjacent if they are neighbors and the gray levels are similar. Okay, adjacency means if two pixels are adjacent if are the neighbors and the gray levels are similar. Okay, then V set of gray levels. Similar gray level means that the gray level of the both pixels along with the set of V. For example, binary value V is equal to 1 means gray level image will be 32 to 64. And same as we have a 4 adjacency, 8 adjacency, 4 adjacency, broken path, 8 adjacency, multiple path conditions. So this is a concept M adjacency, that is two pixel P and Q with the values of V are M adjacent. If Q is in N4 of P or Q is in ND of P, and the intersection of N4 of P and the N4 of Q has no pixels with the values in P. So region, a subset of pixels in an image. So R is called a region if every pixel in R is connected to any other pixel in R. Boundary, that is called a border or counter, so of the region. So set of pixels in the region that have one or more neighbors that are not in R. So these are the connected components. So this is a distance measure between the one pixel to another pixel for pixel P, Q and Z with the coordinates x comma y, s comma t and v comma w respectively. So d is a distance functions if. So d of p comma q greater than 0. So d of p comma q is equal to d of q comma p, like that we can define the distance equation. Linear and nonlinear operations, very H, an operator whose input and outputs are images. H is a linear if for any two images F and G are any two scales A and B. Okay, this is the equation for linear and nonlinear operations. Okay, let's see one by one. Digital image processing, image segmentation, that is thresholding. Okay, first we need to know what is thresholding. So thresholding is usually the first step in any segmentation approach. So we have talked about simple and single value thresholding already. So single value thresholding can be mathematically follows g of x comma y is equal to 1 if f of x comma y greater than t, if 0 means less than t. Okay, that is threshold concept. So imagine a poker playing robot need a visually interrupt the card in this hand. Okay, that is we have a, if you're using original threshold measurements, you can get the number of cards and card flower details. Okay, if we get the threshold wrong, the result can be disastrous. So first image defines the threshold to take too low. Second image defines the threshold too high. So based on the histogram of an image, so partition the image histogram using a single global threshold. The success of these techniques very strongly depend on how well the histogram can be partitioned. Okay, so the basic global thresholding algorithm. The basic global threshold T is calculated as follows. So select an initial estimate of T. So second one will be segment the image using T to produce the two group of pixels. G1 consisting of pixel with the gray level T and G2 consisting of pixel with the grade level less than of T. So compute the average gray levels of pixel in G1 to give mu1 and G2 to give mu2. So this is the compute the new threshold value T is equal to mu1 plus mu2 divided by 2, that is average of two values. So this algorithm works very well for finding threshold. So when the histogram is suitable. This is the threshold examples. So problems with the single value thresholding. So single value thresholding only work for the bind model histograms. So image with other kind of histograms need more than a single threshold. Okay, let's say we want to isolate the content of the bottle, then think about that what the histogram of this image would be like and would be used in the single threshold value. Uneven illumination can be really upset a single valued threshold schemes. So basic adaptive thresholding, an approach to handling situations in which single value thresholding will not work is to divide an image into sub image and threshold this individually. So since the threshold for each pixel depends on its location within an image, so this technique is said to be adaptive. So basic adaptive examples. The image below shows an example of using adaptive thresholding with the image previously, as can be seen such is mixed. But we can further subdivide the troublesome sub-images for more success. So our adaptive threshold example. So these images show the troublesome part of the previous problem for the subdivision. After the subdivision, the successful thresholding can be achieved. Okay, these are the concepts used in the basic threshold concepts.